Okay, now we are going to see the hybrid parameters. Hybrid parameters is represented by H parameters. The standard equation of H parameters matrix form will be like this. When we are expressing V1 and I2 as a dependent variable in terms of I1 and V2 as an independent variable, we are getting the hybrid parameters. So when we express V1 and I2 in terms of I1, V2, we'll get the hybrid parameter. Okay, so the standard equations will be V1 is equal to H11 I1 plus H12 V2. Second equation is I2 is equal to H21 I1 plus H22 V2. So these two are the standard equation of H parameter. Now we have to define what is H11, what is H12, H21, H22. What is the name of this 4 H parameter? So that we can obtain by keeping V2. Now to find out what is H11 and what is H21, we have to keep V2 0. So case first, when output port is short circuited. So when output port is short circuited, V2 is 0. So when V2 is 0, from equation 1 we are getting H11, and that is V1 upon I1. Okay, this is the ratio of input voltage upon input current, therefore it is the input impedance. So H11 is nothing but it is the input impedance when output port is short circuit. Okay, so in this way we will define H11. H1 is nothing but input impedance of two-port network when output is short circuit. Next is from equation 2 we are getting H21 when V2 is 0. H21 is equal to I2 upon I1. So H21 is equal to I2 upon I1 when V2 is 0. Output variable upon input variable, therefore it is a forward and is a ratio of current. So it is a forward current gain when output is short circuit. So H21 is called as the forward current gain when output is short circuit. Okay, this is called as HF. This is represented by HF in a transistor analysis. This is represented by HI because the input impedance. Okay, F stands for forward. Now to find out the next two parameter H12 and H22, we have to keep I1 0. I1 means input port open circuit. So case 2, when input port is open circuit, that is when I1 is 0. From equation 1 we are getting H12. H12 is equal to V1 upon V2. V1 upon V2. So it's a ratio of input variable upon output variable, therefore it is reverse voltage ratio. So H12 is reverse voltage gain or reverse voltage ratio when input is open. Then this is represented by HR in transistor. Okay, next is H22 is nothing but I2 upon V2. So H22 is I2 upon V2, output current upon output voltage, so it is the output admittance when input is open. So if in this way we will define this H parameter. Now if you see H11 is impedance, this impedance, current gain, voltage gain, admittance, input, output, forward, reverse. So this is a mixture of all. Okay, so since it is a mixture of all, this is called as hybrid parameter. Okay, so in this hybrid parameter, while defining this H parameter, we are getting input term, output term, impedance, admittance, reverse, forward, voltage gain, current gain, short circuit, open circuit, and therefore this is we call as a mixture of all, and hence its name is hybrid parameter. Okay, now the next what we are going to see is condition of reciprocity in terms of H parameter. So the condition of reciprocity in terms of H parameter. So consider this network. Okay, input is applied to input port, output short circuit current is which is a response will observe from the output port. And here we have to find out the excitation to response ratio. So excitation is Vs, response is I2 dash. So using this standard H parameter equation, we have to find out Vs upon I2 dash ratio. So what is given from the network is V1 is equal to Vs. Since output port is short circuit, V2 is 0, and I2 and I2 double dash are equal in magnitude but opposite in direction, and therefore I2 is equal to minus I2 dash. Okay, so which equation will use to find out this Vs upon I2 dash ratio? So V1 is replaced by Vs, so here V1 is replaced by Vs and I2 is replaced by I2 dash. I2 is replaced by I2 dash. Okay, So what we are doing is ki from equation 2 we'll find out the I1. Okay, and we'll put this value of I1 here, so that we'll get the Vs upon I2 dash ratio. Okay, so let us see how will you find out this. So from equation 2, I2 is nothing but minus I2 dash, H21 I1 as it is, V2 is equal to 0. Okay, so from this is I1 is equal to minus 1 upon H21 into I2 dash. Then equation 1 becomes, so we'll find out from equation 2, we'll find out the value of I1 in terms of I2 dash, and that we'll put here in equation 1. Okay, so equation 1 becomes V1 is nothing but Vs, H11, I1 will replace it by this term, minus 1 upon H21 I2 dash, plus V2 is 0. Okay, and from this is Vs upon I2 dash ratio is minus H11 upon H21. So from equation first of all, from equation 2 we'll find out I1, and then from equation 1 we'll replace I1 by this equation, and then we'll obtain Vs upon I2 dash ratio, which is equal to this one. Now we'll interchange excitation and response in second case. Now input is applied to the port 2, so therefore V2 is equal to Vs, and short circuit current is observed at the port 1. So since the port 1 is short circuit, V1 is equal to 0, I1 is equal to minus I1 dash. Okay, so from equation 1, okay, from equation 1 V1 is equal to 0, I1 is equal to minus I1 dash, and V2 is equal to Vs. So from this equation 1 you are directly getting Vs upon I1 dash ratio. So ये term ये side में लेके आए, and then we'll find out Vs upon I1 dash ratio. So Vs upon I1 dash ratio is nothing but H11 upon H12. So Vs upon I1 dash ratio is H11 upon H12. This is we got equation 4. Network is reciprocal only when these two equation 3 and 4 are equal. Equation 3 and 4 का numerators are equal है. Okay, so equation 3 and 4 are equal only when their denominators are equal. So the condition of reciprocity is H12 must be equal to minus H21. So when H12 is equal to minus H21, any two-port network is said to be reciprocal. So this is a condition of reciprocity in terms of H parameter. Okay, then we'll see the condition of symmetry in terms of H parameter. So the condition of symmetry in terms of H parameter. Network is symmetrical when input impedance is equal to output impedance when one of the port is open, when other port is open circuit. These are the standard equation of H parameter. From this equation, in first case we have to find out V1 upon I1 ratio, and from these equations, from second case we have to find out V2 upon I2 ratio. So case first, we have to keep I2 0 and obtain the ratio V1 upon I1 from these two equations. So when I2 is 0, we have to find out V1 upon I1. Okay, so from equation 2, when I2 is 0, I2 is equal to 0, H21 I1 plus H22 V2. Okay, so we are getting V1 upon I1 ratio from equation 1 only when we'll replace V2 from the equation 2. Okay, so we'll obtain from equation 2, we'll obtain V2, and we'll put this value of V2 in equation 1, and then we'll obtain V1 upon I1. So therefore from equation 2 we have to find out first of all V2. So I2 0 rakha, and we'll find out the V2. So I2 0 रख के V2 will be this one. This term इधर transfer किया, and V2 is equal to minus H21 upon H22 into I1. Then put this value of V2 in equation 1, and then obtain V1 upon I1 ratio. So equation 1 becomes V1 is equal to H11 I1 plus H12 V2. V2 is replaced by this one. Now I1 is taken out common from this equation, and it will be like this: H11 plus minus H12 H21 upon H22. If we do the cross multiplication, the numerator term will be del H, that is determinant of H parameter matrix. So del H upon H22. So V1 upon I1 ratio when I2 is 0, you are getting equal to del H upon H22. Now next is you have to find out V2 upon I2 when I1 is equal to 0 from these two equations. So case 2 is what it is. When I1 is equal to 0, how to get V2 upon I2? So when I1 is equal to 0, V2 upon I2 you are directly getting from equation 2. Okay, so from 2, I2 as it is, I1 is 0 and S22 V2. So therefore V2 upon I2 is 1 upon S22. Now network is symmetrical only when equation 3 and 4 is equal. Equation 3 and 4 is equal only when this del H must be equal to 1. So the condition of symmetry in terms of H parameter is del H should be equal to 1. That is, determinant of H parameter matrix must be equal to 1. Okay, in this way we'll define all the 4 parameter: Z parameter, Y parameter, transmission parameter, H parameter, and we have seen that the condition of reciprocity and condition of symmetry. Okay, thank you.